Take a look around you. They're in your home, your backyard. They're everywhere. They've been around for over 250 million years. One of nature's great success stories. There are as many different kinds of beetle as there are foods they can feast on. Meat eaters, vegetarians, and even cannibals live side by side. Earth is teeming with these amazing little animals. Welcome to Beetle Mania. When it comes to a contest of numbers, beetles are the undisputed winners. There are around 300,000 species in the world today. That's almost a third of all animals. They're incredibly adaptable and found almost anywhere, from lush forest to stony deserts. And their design is as variable as their habitat. They range in size from 1/4 of a millimetre to 20 centimetres in length. They can be hairy or smooth, thin and delicate, or horned, armoured giants. All beetles have tough forewings that act like armoured plates and meet on their back to cover delicate hind wings. They can be good flyers, but some have developed a flightless existence. A beetle's 6 legs are also designed for a specific lifestyle. Legs can be built for speed, long and slender like the tiger beetles, or broad and built for digging like the dung beetles. Water beetles have even developed curved paddles to help them swim more efficiently. A beetle's mouth parts are also highly adapted to an individual way of life. The tiger beetle's terrifying jaws are large and sharp, ideal if you're a predator, while weevils have small, hard mouth parts at the tip of an elongated snout, designed for crushing plant material. The beetle's control centre is its head, but it doesn't contain a sophisticated brain. It's more a concentration of nerve junctions. The head also carries sensory receivers like eyes and antennae. Tiny, vibration-sensitive hairs cover its entire body. The majority of beetles have compound eyes and probably see in colour. Those relying on vision for hunting or mating have larger, more efficient eyes, able to detect prey even at a distance. A beetle's antennae are vital for obtaining information. They house receptors that are sensitive to stimulants like humidity or vibrations. But the appearance and purpose of antennae is fantastically varied. They're generally used to find food or a potential mate. Males tend to have much more elaborate antennae since they have to seek out the females. Some, like these male stag beetles, even have prominent antlers, used to wage war on competitors. Attacks from predators are an ever-present threat. Hard, shiny wing cases form the first line of defence. Ladybirds retract their legs and antennae under the protective shield, clamping onto the ground and waiting until it's safe to emerge. Some ladybird larvae have hollow spines that, when ruptured, release a sticky yellow fluid that acts as a chemical weapon. Adult ladybirds produce the same substance from their leg joints. If, for example, an ant seizes a ladybird's legs in its jaws, the yellow juice gums up the attacker's antennae and mouth parts. The use of repellent chemicals for self-defense is widespread amongst beetles, and when danger threatens, some even unleash concoctions like formic acid or boiling gases. But defense doesn't always take the form of open attack. Some beetles simply taste awful, a fact which they advertise with bright, distinctive colour patterns. Sound can also be a deterrent. Like an electronic alarm, a sudden unexpected squeak can be enough to make a predator drop a tasty beetle, and many ground beetles benefit from this tactic. Perhaps most impressive is the beetle's adaptation to a massive variety of food sources. They range from predators to dung feeders and even parasites. The majority feed on plants. It's virtually impossible to find a plant that's not attacked by at least one type of beetle. But feeding on plants presents problems. Plants are largely composed of a tough material called cellulose. A special enzyme is needed to break it down to sugar. Very few beetles are capable of producing the necessary enzyme, but they've found a solution. Many have formed relationships with bacteria or fungi that can produce the enzyme. These live in special pockets inside the beetle's gut. There are also beetles that feed on decaying flesh, beetles that raid insect nests, and beetles that eat beetles. Cannibalism is common amongst ladybirds, who will eat both their own eggs and larvae. It can be a successful strategy. By reducing the competition for food, it increases the chances that some ladybirds will survive. But if you're after raw killing power, meet the predatory ground beetles. Fast, with good eyesight and terrifying mouthparts, they wreak havoc wherever they're found. In Europe, we find an incredible predator, the cheetah of the beetle world. This is a tiger beetle, a killer sprinter. They live on dry, sandy ground where the grass cover is just right. Not too thick and with open patches, ideal for stalking and killing. Tiger beetles are fearsome hunters, designed for speed and accuracy, with long legs to chase prey and sharp eyes to locate it. They sprint in a series of short bursts, covering around 60 centimeters per second. That's like a racehorse galloping at 320 kilometers per hour. Their favorite food is ants. There are lots of them, if you can catch them. The pursuit is interrupted by brief stops. That's because the beetle's eyes are made up of many tiny lenses with limited resolution. Fast movement tends to blur the image. The beetle must come to a halt if it wants to get an accurate fix on its prey. Once caught, the beetle uses its rear jaws to move the unfortunate victim into a good position for the main jaws to crush it. But incredibly, the fight isn't over. The ant's jaws remain clamped to the beetle. It's a last attempt to defeat its killer. Beetles also have predators and have developed chemical weapons against their attackers. This soldier beetle produces a chemical spray that deters birds from picking on it. But will it work against a tiger beetle attack? As the tiger beetle pounces, the soldier beetle employs its weapons. Its abdomen is curved towards the attacker, and it sprays repellent chemicals. But disappointingly, they don't appear to affect the hungry tiger beetle. It's a one-sided battle. The tiger beetle's strength and speed mean it has no trouble overpowering its victim. Soldier beetles are not particularly well armoured, possibly because its chemical defences are normally effective. But in this contest, it loses out massively. It's simply no match against the hunting skills and powerful mouthparts of the tiger beetle. The tiger beetle crushes its victim and feasts on juices and soft inner parts. All the goodness is sucked out until only the shell of its prey is left to be discarded. Rove beetles are more successful when it comes to saving their skin. They may seem relatively unprotected given their short wing cases and exposed soft body. But the point of having short wing cases is to be flexible enough to wriggle into confined spaces, fold up and protect long wings, and apply its very own chemical defense system. Under attack from predators like this harvest mouse, the rove beetle simply raises its abdomen and squirts a cocktail of chemicals into the attacker's face. This not only confuses its potential killer, the chemicals are irritating and painful, even able to blister human skin. Abandoning its potential meal is the only option for the killer mouse. One of the most impressive beetle warriors is the bombardier beetle. It's a walking chemical laboratory. Would-be predators are deterred by spraying them with boiling hot quinines, noxious chemicals that cause blistering of the skin. The chemicals are produced by special glands and stored in an abdominal chamber. When needed, they're discharged into a combustion chamber and exposed to a specific enzyme. The violent chemical reaction that follows generates heat and produces quinines, water and oxygen. The effect of the chemicals is instant, and even a ferocious predator like the Australian wolf spider retreats quickly. Water beetles also use chemicals to defend themselves against predators. But first, the basic beetle design needs a few adaptations to create a fully functional underwater creature. This beetle breathes by trapping a bubble of air using water-repellent hairs on the tip of its abdomen. Its eyes are also specially adapted for underwater vision. Even its legs have become miniature oars with a dense fringe of hairs growing on their sides. Fish like this perch also live here. Another voracious predator hunting in the same grounds, ready to eat anything that moves. But the water beetles are well armed. When attacked, the beetles produce a chemical substance that causes the fish extreme distress. A couple of tastes of water beetle soon teach young perch to stay well clear. On the surface of the water, a different kind of beetle makes its living. Whirligig beetles cruise about like miniature paddle steamers. Whirligigs are typical water beetles, with boat-shaped bodies and airtight wing cases. But their eyes are something special. They're divided into two parts, one designed to see above water, the other to see below, at the same time. Its eyes allow the beetle to watch out for danger both above and below the surface simultaneously. Their legs are also perfectly modified to suit an aquatic lifestyle. They're like large flat paddles, not bristly like the water beetles. Whirligigs find their food by detecting vibrations on the water surface. These lead them to dead or dying insects that have fallen into the water, often some distance away. Bizarrely, once a whirligig beetle finds its victim, it repeatedly whirls it around before settling down to eat. As you'd expect, other beetles detect the commotion and arrive at the scene. But this tactic appears to be deliberate. It not only debilitates struggling prey, but sharing your food with others means there's more to go round for everyone. When under threat, whirligigs resort to the most tried and tested method of getting out of danger's way: retreat fast. Once below the surface, they hang on to vegetation until the threat has passed. As the whirligig dives, it takes an air bubble with it so it can breathe. But the bubble can cause trouble. Should the buoyancy of the air bubble exceed the weight of the anchor, the beetle will float back towards the surface and within reach of predators. But overall, their disappearing act is successful, usually getting them out of the way of hungry hunters just in time. Other beetles have developed equally successful ways of keeping predators at bay. A tiger beetle trying to prey on a ladybird will come across a major obstacle: the ladybird's tough wing cases. Try as it might, it simply can't get a grip on the strong, slippery surface. The ladybird is just too tough, and as long as it keeps a strong grip on the ground, the tiger beetle won't be able to hurt it. The ladybird's armoured plates are a formidable defence against brute force. Keeping low to the ground to avoid being turned over and staying still are also effective strategies. And since this hunter only responds to moving targets, it soon loses interest if the ladybird stays put. With good timing, the ladybird can make a quick and safe exit. A soft-bodied spider would seem an ideal meal for the hungry tiger beetle after its failed attempt on the ladybird. But against the odds, this tiny crab spider uses deception to outwit the attacker. It seems to be determined to have a go, and even appears to attack the ferocious tiger beetle. By stretching out its front legs and rearing up, the spider manages to make itself look bigger and more intimidating than it really is. Its would-be predator is convinced and prefers to retreat without attacking, leaving the tiny spider to go about its business as usual. Ultimately, the safest way to escape death is to get out of striking distance as soon as possible. The ladybird escaping the tiger beetle by flying off is a common strategy amongst beetles. Ladybirds have disproportionately large wings for their size. They're necessary to support their tubby bodies and to give them enough speed to escape from predators. But when it comes to folding up such massive wings, life gets complicated. Considering the design of their wings, it's a surprise that beetles are such good flyers. In the air, the hardened cases of the outer wing act like the wings of an aeroplane by providing stability and lift. But the powerhouse of beetle flight is the hind wings. These delicate propellers are folded neatly and tightly away under the protective outer cases when they're not in use. But all the beetle has to do is tense just one group of muscles to unfold these motor wings. It's a very efficient method of making an escape. There's a massacre happening in the miniature world that surrounds us. Ladybirds aren't just great escape artists. Despite their cute name, they're deadly. In fact, without them, greenfly populations might become a serious problem. One ladybird can eat up to 5,000 greenfly in its lifetime. And they're not the only ones who enjoy a meal of greenflies. Ladybird larvae are just the same, and hunt on plants for aphids side by side with the adults. They gorge themselves on the ready supply of prey for about 3 weeks, until they're ready to mature into adults. But if you think those little killers were impressive, watch out for the larva of the tiger beetle. Holes in the ground of this meadow make it a dangerous place to be for caterpillars and other small prey. The holes conceal a cunning hunter. The tiger beetle larva waits at the top of its tube, perfectly camouflaged and its head flush with the ground. Like its parents, the tiger beetle larva has fearsome jaws and is able to move extremely quickly. And although its eyes are simple, they can still locate prey coming into strike range. Foraging ants are this miniature killer's most common victims. The larva shoots out of its tube and grabs the unsuspecting ant. The kill is over in a flash. There are always a few who have lucky escapes. The two-spot ladybird is another victim, despite the protection of its body armour or carapace. Only if the larva manages to get a grip on its soft belly is the ladybird done for. The larva is unable to move except up and down. It has 2 small hooks on its body, which are designed to dig into the burrow's walls and give the larva extra support, especially when tackling powerful prey like caterpillars. Watch how the tiger beetle larva waits for a caterpillar to come just within range before shooting out of its lair and taking the unlucky victim totally by surprise. It throws its head backwards to grab the prey with sickle-shaped jaws before pulling it into its lair. The larva punctures the body before secreting digestive juices that help break down the tissues of its prey. Keeping its burrow and feeding chamber in good repair is crucial to the survival of the tiger beetle larva. Should the weather turn, rain hammers down onto the burrow opening. The well-drained soil tends to collapse. Although the water will drain away and cause no lasting damage, the sand and gravel clogging up the narrow passageway to the top must now be removed. As the clouds disappear and the rain stops, the larva gets ready for some vital housework. This is one of the disadvantages of being an ambush predator like this larva. A lot of time is taken up clearing and tidying, making sure your trap is in perfect condition. Once everything is neat and back in place, the larva is ready to invite the next victim for lunch. Some potential victims are protected against the larva's fearsome attack, the 7-spot ladybird being one of them. It's bigger and better armoured than the unfortunate 2-spot we saw earlier, It's simply too much for the tiger beetle larva to handle. Although the attack seems to have left the ladybird somewhat disoriented. The larva is only an early temporary stage in the development of an adult tiger beetle. Its life cycle would have started during the tiger beetle mating season in spring. Their courtship is brief, more like a quick rough and tumble that tells the male if his potential partner is receptive. Once things are looking hopeful, the male mounts the female and grips her tightly with his feet, which tend to be larger specifically for this purpose. But the course of true love never ran smoothly. Occasionally the males get confused. They normally identify the female by scent, but mistakes can happen. Watch how a second male turns up and, believing he has found a mate, starts to mount the male who has beaten him to it. Very confusing. It's a ménage à trois, Beetle style. Once mated, the tiger beetle female ceases to be receptive and is ready to lay her single egg. Being ground dwellers, tiger beetles lay their eggs in the soil and leave them to develop into adults on their own. There's no parental care. Choice of habitat is crucial. The soil has to be light enough for the female to dig into and well drained enough for the egg to remain moist without becoming waterlogged. It seems like a gamble, but over time the female has evolved to make a series of crucial decisions that usually ensure her offspring's survival. Ladybirds couldn't be more different. They lay their eggs in batches stuck to leaves. These are the eggs of a 7-spot ladybird. Whilst they may look as if they're placed at random, the reality is that they're well hidden from potential predators amongst the foliage. More importantly, the larvae that will hatch from the eggs will be immediately surrounded by an abundant food source, greenfly. Watch as the ladybird offspring develop in the space of just a few days, from eggs to larvae, which all hatch together before swarming out with a single purpose in mind: to kill. The young assassins hunt by chasing down their prey on plants like roses or nettles, where greenfly are likely to be found in abundance. A brutal massacre taking place right under our noses in our own gardens. Initially, the predatory larvae feed on nymphs, the greenfly's babies. The ladybird larvae are around in such numbers that they have a marked effect on greenfly populations. It's no wonder they're known as the gardener's friend. This feeding feast takes place in spring and early summer, each larva consuming up to 50 greenfly a day. That's over 1,000 during their larval stage alone. After a period of frenzied feeding, the ladybird larva attaches itself to a leaf stem and turns into a pupa, a process that takes several hours. Watch as the pupa hardens and turns brown. The developing adult inside is protected by a tough outer skin. A few days later, and the fully formed adult is ready to emerge. It crawls out of its fortress, and as its wings dry, it turns into the familiar 7-spot ladybird. Meanwhile, the tiger beetle larva has undergone a similar miraculous transformation. Its pupa is safely tucked away underground in its former feeding chamber, and since it's so well protected, its design is quite different from the ladybird pupa. Since the larva is susceptible to mildew and needs to be protected from damp, spines on its back serve as props to suspend it from the ground. There's another crucial difference between the tiger beetle larva and that of the ladybird. The tiger beetle won't emerge from its burrow this year. Instead, it will spend the winter underground, only to emerge in the spring. As the weeks go by, the pupal case changes colour and texture. By late autumn, it finally begins to take on some of the adult colours. The ladybirds deal with the onset of winter in a different way. As the nights draw in and the weather gets colder, they start to prepare. Soon, it will be too cold for them to fly. They find hiding places amongst the leaves. Even if the leaves fall to the ground later on, they'll still provide valuable shelter. Sometimes the ladybirds gather in clumps, like on these evergreen shrubs. Once milder temperatures announce the arrival of spring, it's finally time for the shiny new tiger beetle to emerge from its burrow. From the very beginning, this beetle is a perfectly designed hunter and even a good flyer. But ultimately, the tiger beetle is designed to be a ground predator. Even though this hunter's fantastic design protects it from most attackers, sometimes the odds are stacked too heavily against it. A young tiger beetle makes a perfect snack for this hungry toad. Elsewhere in the world, beetles follow a different pattern of birth, death and rebirth. The plains of Africa are home to large herds of massive plant eaters, like elephants. And where there are elephants, there will be lots and lots of busy beetles. A single elephant gets through about 250 kilograms of plant food a day, but it also returns most of it to the ground in huge heaps of dung. The fact that Africa's plains aren't covered in knee-deep elephant dung is down to millions of dung beetles, whose life is dedicated to clearing up the mess. There are over 2,000 different kinds of dung beetle in Africa alone. This one is an elephant dung specialist. It's known as a dung roller. Using its front legs, it picks up as much dung as possible and makes it into a neat ball. Time is of the essence in this game. Go too slow and the dung will dry out. And there are many other beetles competing for a share of the treasure. Some of the smallest dung beetles make their living inside the balls made by the bigger ones. And if too many get in, the ball becomes useless to its original maker. This takeaway method has its own risks attached, not least continued piracy attempts by other beetles. Fierce battles start all over the dung heap. If the battle goes on too long, both fighters will be losers. Time spent away from a dung ball gives more and more small beetles the chance to burrow into it. A ball owner can sense how many small beetles have got into its ball, and if there are too many, it will abandon the project to make another. An average elephant dropping attracts beetles and flies in astonishing numbers. Competition is intense. Nearly 4,000 beetles can arrive in the 15 minutes after dung is first dropped. An hour later, nearly all of it will have been buried or dispersed. Every delay in getting away with the prize leads to another mugging attempt. Eventually, the beetle makes a break for it. Now it climbs on top of its precious ball every few turns to have a look around. It's searching for a nice shady area, maybe up to 15 meters away. Once the beetle has managed to leave the dung pile behind it, progress is more rapid, sometimes a bit too rapid. When it's reached its destination, the beetle sets about burying the ball. At this time of year, the start of the wet season, this newly emerged beetle is collecting dung for food. In a couple of weeks, the ball will have been devoured, and the beetle re-emerges to repeat the whole process. These beetles are so efficient that in Australia, where the existing insect fauna is unable to deal with the large amounts of dung produced by introduced cattle, beetles have been imported from Africa and South America to help keep the problem under control. This is a male stag beetle. It's an armoured giant amongst beetles and the largest beetle found in Europe. And this is what it's looking for: a female willing to breed. Although her mouthparts are considerably less impressive than the male's massive antlers, don't be deceived. They're much stronger. But the male's antlers aren't used for hunting or feeding. They're specifically designed to impress potential mates and to outmaneuver any rivals. What we've got here is two males interested in the one female. They size each other up before launching an embittered battle for the right to breed. Whilst the males fight, the female waits patiently for the outcome of the contest. Finally, it looks like one of the males has the upper hand. But while the fighting males are caught up in their dispute, another male has come on the scene. Staying on the sidelines, he takes advantage of the commotion. He grabs the female and mates with her. The two fighters are still locked in battle, oblivious to the fact that their efforts will be wasted. The victorious stag beetle eventually returns to claim his prize, but he finds himself confronted by the male who has already mated with the female, and a new battle starts. It's all too late for quarrelling. The female is already on her way to lay her eggs. The sneaky male won out. The stag beetle who won the first fight has wasted his efforts. He's left high and dry. No matter how strong and impressive he might be, this time he's been outwitted. Beetles have been associated with humans and their houses ever since we began to establish a more settled way of life. Truth be told, they're all around us. Some can have devastating effects on our economies and livelihoods. Homes built of oak wood and described as safe as houses are especially prone to the attack of the death watch beetle, turning them into crumbling wrecks. The deathwatch beetle's natural home is in oak trees, where it does an important job in breaking down dead matter. But oak used to build houses also makes a perfect habitat. During the breeding season in spring, the adult beetles communicate by producing a clicking sound. This is what gave them their name. It's a sound you might hear in the dead of night when following the old tradition of watching over a corpse. Both males and females tap to advertise their position, moving towards the sound made by a potential mate. But it's the grubs that do the damage to the wood. They burrow away in the timbers, mainly feeding on fungus that's already there. But the effect is to leave the wood honeycombed and weakened, eventually killing the building. The woodworm beetle also invades our homes with potentially devastating effect. And we usually don't know it's there until it's too late. Woodworm beetles are detectable by the presence of tiny round holes in the wood. These are the adult's flight holes, although the ability to fly isn't always a protection against unforeseen events. As a legless larva, this beetle would have chewed tunnels through wood, a much safer way to spend your time. Incredibly, it feeds on the wood itself rather than a fungus within it. Symbiotic organisms live inside the beetle's gut and enable it to digest such unpromising foodstuff. And although woodworm normally spreads like wildfire, this unfortunate beetle at least will be unlikely to contribute to the systematic destruction of furniture and building materials. This small creature is a weevil, one of a group of beetles that have had a huge impact on the way we humans live. Some weevils live inoffensively on plants, but others have learned to take advantage of stored human food. Take these grain weevils. Here they hatch in and eat large quantities of wheat, but they'll also go for stored rice and other cereal crops, spreading rapidly and contaminating the store with their droppings. Weevils cause billions of dollars worth of damage worldwide every year. They're one of our oldest enemies. Bean weevils work in much the same way. invading large quantities of the harvest and eating away at the precious beans. The corn weevil does the same to stores of maize and corn, systematically destroying entire harvests. In fact, there are almost as many kinds of pest beetle as there are types of stored food. One beetle with a very distinguished taste even opts for tobacco. Cigars appear to be very delicious, and an infestation of tobacco beetle can cause serious economic damage. There's even a beetle that lives on smoked and a food and most bacteria. You guessed it, it's called the bacon beetle. Here it is, the voracious beetle larvae that do the damage. When it comes to modern beetle pests, the Colorado beetle is a frightening example. The brightly coloured adults and larvae feed on the leaves and stems of potato plants, preventing the production of tubers. A heavy infestation will devastate a whole crop. Until the mid-19th century, this pretty beetle lived in the Rocky Mountains of America, feeding on wild relatives of the potato. But when the first settlers started to cultivate potatoes, the beetles found them much more attractive than the wild alternative. So much so that they regularly wiped out the entire potato crop of the American West. The Colorado beetle's voracious appetite is matched only by the speed at which they reproduce. One female can lay up to 2,000 eggs in her lifetime, and there can be up to 3 generations in a single year. Genetic engineering has created plants with inbuilt toxins that protect them against the Colorado beetle. But these toxins may be passed on to useful insects like ladybirds, a side effect that will create a whole new set of problems. For around 250 million years, beetles of all shapes and sizes have lived on Earth. They're the toughest and by far the largest group of insects we know. There are so many of them that about 1 in 4 of all animals is a beetle. They have such a dramatic impact on their surroundings that they're man's main competitor for food. Grain weevils alone destroy 1/3 of the world's grain crop every year. Beetles are of incredibly varied designs, each perfectly suited to a particular way of life. And there are about as many different lifestyles amongst beetles as there are potential food sources. But why are there so many beetles? What sets them apart from other animals? More than half of beetles are plant feeders. Every time they colonized a new plant, the plant fought back, and the beetle had to adapt. Over time, the diversity of the beetle increased hugely. Plant-feeding beetles generally have a huge advantage over their predatory or scavenger relatives, simply because there are so many plants in the world. They're so successful that even now there are plant-dependent beetles that were around 200 million years ago. They're like living fossils, still doing today what they were doing back then. Beetles have also formed intricate relationships with people since we first appeared on Earth. While some damage our way of life, not all are harmful. Some are welcome additions to our environment. Ladybirds control pests like the greenfly. They're so effective that we breed them on a commercial scale to be used as biological control agents. Other beetles have been used to deal with invasions of foreign plants and animals. But one thing's for certain, humans will be obsessed by beetles for many years to come. Beetle mania is here to stay. And their design is as variable as their habitats. They range in size from a fraction of an inch to almost 8 inches in length. They can be hairy or smooth, thin and delicate, or horned, armoured giants. They sprint in a series of short bursts, covering around 2 feet per second. That's like a racehorse galloping at almost 200 miles per hour. They sprint in a series of short bursts, covering around 2 feet per second. That's like a racehorse galloping at almost 200 miles an hour. A single elephant gets through about 550 pounds of plant food a day, but it also returns most of it to the ground in huge heaps of dung. The fact that Africa's plains aren't covered in knee-deep elephant dung is down to millions of dung beetles, whose life is dedicated to clearing up the mess. Eventually, the beetle makes a break for it. Now it climbs on top of its precious ball every few turns to have a look around. It's searching for a nice shady area.